from our equation, we can state that if Sm is entropy or entropy have positive value, and net T or net temperature or value of a net temperature more than 0, where the final temperature is more than initial temperature, so this make our net temperature will be more than 0. So there will be decrease in molar gives energy value. So our molar gives energy will be less than 0. Besides, at a given change of temperature, the change in molar gives energy will be proportional to the molar entropy. So here is the observation that we can have from our equation here. And we need to know that the gas has a more special disorder than liquid and solid phase. Thus, the delta molar entropy of a gas is more than liquid and more than solid. So here is the three relationship that we can have from our equation there. And besides, you also can prove your answer in 3B by sketching graph. So you can refer to my lecture note how to sketch graph of for this equation. Okay, next, let's move to question 4. Question 4 asks us to calculate delta G at 290 K. K is in Kelvin for the following reaction. Given the following reaction, the production of nitrogen dioxide, given 2 mole of nitrogen oxide in the gas form, react with oxygen gas, O2, and it become 2 mole of nitrogen dioxide. Given the delta H, the enthalpy of the reaction is negative 440 kilojoule, and our entropy or delta S equal to negative 160 joule per Kelvin. And again, because the question asks us to calculate delta G, we know that the formula of delta G equal to delta H minus T delta S, and then we need to identify all the value from the information given in the question. So in this equation, give delta H, so and also give it delta S. So but we need to know, that our delta H is given by kilojoule, while for delta S given joule. So we need to know how to convert the unit here. So either you want to convert it to kilojoule or joule, is depend on you. Okay, and then after we have that, after we determine or identify all the value, we can try to substitute all the value to their respective. So for example here, delta H equal to 150 kilojoule. I take it from here. T, we know that T is 290 kelvins here. And so our delta S is entropy 160. So what I do here is 160 because I want my answer in kilojoule. So that's why I times it with 10 power of negative 3. So here is the factor to convert joule to kilojoule. So I will have a kilojoule per Kelvin here. So the units, now the units is uniform. The dimension is uniform. So because we need to make sure our dimension is correct. Otherwise, we will calculate it wrong, and then our final answer will be minus 93.6 kilojoule, or if you want to convert it to joule, it will be minus 93,600 joule. So for you to get this joule, you need to convert it to joule, kilojoule to joule. So you will have 140 times 10 power of 3, and then we will don't have this, and the unit will be joule. So from our answer, we can state that our Gibbs energy will be less than 0 because we have a negative 93,600 joule or 93.6 kilojoule. It is less than 0. So this fraction is spontaneous. We can look at that. Next, let's move to question 5, which is our final question for today. So the question 5 is regarding about a phase diagram, how to interpret this phase diagram. So the question gives us the phase diagram of substance S, and it consists of 4 sub-questions, which is the first question asks us to explain the information that we can extract or we can obtain from our phase diagram in figure 1. And then later on, by referring to figure 1, try to label the triple point, critical point, and then also phase boundary. And for C, by referring your answer in 4B, our previous question, try to explain what is triple point, critical point, and also phase boundary. And next is determine the number of degree of freedom of substance S at each of following point by using phase rule. So we already have a formula for this phase rule, and by using the formula we can determine the number of degree of freedom of this substance. So how to answer this question? Let's have a look. So first, question 5A asks us to explain the equation or try to extract the equation that we can get from our phase diagram of phase S. So as you know that phase diagram is a graphical representation that is determined by experimentally to determine the physical state of substance S under different conditions of temperature and also pressure. Our temperature will be at the x-axis and our pressure will be at the y-axis. So all the value were determined experimentally, and as we cross the line or curve of the phase diagram, a phase change will occur. So from here from C to B, from B to A, everything will involve energy, and the phase change will occur. Besides, two states of the substance coexist in equilibrium of the line or curves. So phase change involves the process of sublimation, condensation, evaporation, and others. All of this involved with the energy at a given pressure and the temperature. So from our graph, we can say that area C is a solid, area B show liquid, and area A show gas. So the substance can exist in a 3-phase, which is solid, gas, and liquid. And according to the figure, the substance can exist as solid. Here is solid, so we can see it at our graph. So solid between solid is between the minus 105 to 50 degrees here. See that if we can plot it, it's going to be like this. So at given here, maybe we can say that this is 3 atm to 300 atm. So this, by given this condition, it will be exist in solid, and by using this condition, it will exist as liquid and also gas. So triple point here is the triple point. Triple point exists when the condition is negative 50 degrees Celsius at 6 atm. So go to this one, and this is our critical point. Our critical point will be at 200 degrees centigrade and 300 at 300 atm. So all this information here can be obtained from the graph. Besides, you can have any other relevant point, and you can reduce it, or you can extract it from the graph. Then at each point we can be marked in your exam. So for the question, ask us to label the critical point and also phase boundary. So here is critical point, here is critical point, and this is a phase boundary, and explain what is critical point, and also phase boundary. So what is critical point? Critical point is a surface between two faces disappear, and it's marked the highest temperature where the liquid can exist. This is the definition of critical point. And so you can add one more point if you want. The critical point for this substance is at 200 degrees centigrade at 300 atm. So you can add one more point there. So what is critical point? Critical point is where all three phases, liquid, solid, gas, exist at equilibrium. So it means that the rate of each forward and reverse process are equal, but the composition of three phases not necessarily the same. And the triple point also indicate the lowest temperature where the liquid can exist. And phase boundary are boundary that indicates the condition under which two phases of matter can exist at equilibrium. So for example here, if we can plot this one, so at this point, if we are given temperature 0 and also temperature 30 atm, the solid and liquid will be exist at this point. So this shows as a solid liquid boundaries, while this one is liquid gas boundaries. So here the information that we can extract from our phase boundary. It's just not a graph only. So that is chemistry, where if given you a graph, you know how to interpret the graph. You know that you need to extract from the graph, and a lot more. So by using where you did the experiment, later you need to plot graph, and then from the graph, a lot more information that you can obtain from the graph. It just not necessarily just plot and that this kind, or just see the pattern, but a lot more of definition, abstract information that you can obtain from the graph. And the last question is determine the number of degree of freedom of substance F at each of following points. So using phase rule, we know that our phase rule is F equal to C minus P plus 2, and we can rearrange the formula. It will be P equal to C minus F plus 2. So here is the definition of each of our following term. F is number of degree of freedom, C is number of component, P is number of phases. Since it is a one component system, we can define it as C equal to 1. So if we substitute everything here, we can have 3, 1 plus equal to 3. So our equation will be P equal to 3 minus F. So to determine, if we look at A equal to P3 minus 1, B equal to P3 minus 1. So C as a P, or our number of phase equal to 3 minus 1. So and then we can have